Hi everyone, today we're going to be looking at quartic functions. So we're looking at a step up from a cubic, and a quartic function is just something with a power of 4, right? So we could be looking at something like x to the power of 4, you'd have 3x to the power of 4 plus 3x squared, so on, so on. But your highest power would be 4. Now there's a couple of different forms that quartics come in, just like with everything else. We do have our turning point form. And what you're going to notice when you're sketching a quartic is it's just a bit kind of like fatter than a quadratic almost. And so you're going to have a very flat bottom compared to your quadratic where it was a very clear turning point. And our turning point, once again, is going to be at HK. We also have just the regular polynomial form, or the standard form, as it's usually called, where you've got all of your coefficients for your x to the 4, x3, so on, with your y-intercept at E being our last one. And then we have the factorised form, just like we had for a cubic, that gives you all of your x-intercepts. Now, a quartic graph can have a lot of different shapes. We can have 0 x-intercepts, 1, 2, 3, 4, and so on. If we have 0 x-intercepts, that just means that none of our linear factors have a solution. So we could be looking at something like x squared plus 3 as a factor, and then we've just got no solution for that one. You could have just one x-intercept, so you've got just your one factor that works. So you might have something like x squared minus 3, x squared plus 3, where that first set of brackets has the solution being a turning point, and the second set of brackets has no solution. Now you could have two x-intercepts where one of those is a point of inflection, and in this case you could have something like x plus 3 cubed, x minus 1, something along those lines. That gives you that point of inflection of the cubic. Just like how for with cubics, if one of our factors was squared, that would be a turning point. You can also have 3 x-intercepts and then 4 x-intercepts, okay? But they're the maximum amount of intercepts that you can have. Now, to solve a quartic equation, it's usually easier to factorise if possible. So in this case here, I'm going to take out a common factor of x cubed, and then I've got x minus 6 being equal to 0. So I have x equals 0 from my x cubed and x equals 6 from my x minus 6. Same thing with this one. I'm going to take out a common factor of x squared, and we're going to have x squared and then x squared minus 7x plus 12. I can then factorise that to be x minus 4, x minus 3. So I've got 3 x-intercepts, x equals 0 being a turning point, and then I've got x equals 4 and x equals 3. Now feel free to pause the video here if you'd like to have a go at solving these by yourself, but you follow the same steps as you normally would. So in this case, because I can't factor anything out, I'm just going to move that 81 over and take the fourth root of that. Now just like with a squared, I'm going to have two solutions. I've got positive and negative. This one here, I would take out a common factor of 2x squared, and then I'm going to have x squared minus 4 in the brackets, and that gives me 2x squared, x plus 2, x minus 2. So I've got a solution at x equals 0, x equals negative 2, and x equals 2. Same with this one here. Take out a common factor of x squared. I'm going to end up with x squared minus 2x minus 24 in the brackets. And then I can factor that out using negative 6 and positive 4. So my solutions are going to be x equals 0, x equals 6, and x equals negative 4. Okay? Now for this last one here, you can factorise by grouping, which we have done before. So in this case, I'd have x to the power of 4 plus x squared, and then we're going to subtract 4x squared and 4. So you can kind of pretend it's a quadratic to begin with and then factorise using that fact. Then I've got a common factor of x squared here and a common factor of 4 here, and then I can factorise by grouping. So you can still use all of your tricks with a quadratic. You can still use those with your quartics as well. So our solutions here are x equals positive and negative 2, because without x squared plus 1 we have no solution there. Now, when you are graphing a quartic, you're still going to need the same information that you always need. So you need a turning point if you've been given one, and then your x and y intercepts as well. So for this one here, we'll solve for our x-intercepts first. And I've got 1 is equal to x plus 2 to the power of 4. That's going to give me positive or negative 1 being equal to x plus 2. So I've got x equals negative 3 and x equals negative 1 as my solution there. And then for my y-intercept, if I make x equals 0, I'm going to end up with y equals 2 to the power of 4 minus 1, which is 15. So I've got a y-intercept here at 0, 15. I've got my turning point at negative 2, negative 1. And then I've got my two x-intercepts as well, remembering that this one ends up being a little bit flatter on the bottom than we're used to with our quadratics. And then just label everything as per usual. Feel free to have a go at this one on the right by yourself, but we're going to follow the same rules. I'm going to find my x-intercepts, making y equals 0. So I have 5 being equal to x minus 3 to the power of 4. So now I have the positive or negative 4th root of 5 is equal to x minus 3. So x is equal to 3 plus or minus that 4th root of 5. So we've got two x-intercepts once again, with our turning point happening at 3, 5. Now, because of this negative here, we can see that would be reflected in the y-axis. The 4th root of 5 is about like 1.5 almost. So we're going to have one x-intercept passing through at about 4.5. I'm just going to try that again because that was pretty horrendous. But we've got one passing through at about 4.5 and then another one passing through at about 1.5 there. So this one here would be my 3 plus the 4th root of 5, and this one's going to be 3 minus the 4th root of 5. And then our y-intercept is going to be way down with our turning point here at 3, 5. Okay, so that's how you graph your turning point form for a quartic. Now for this one here, if we're looking for the rule of a quartic, we're going to follow those same steps that we did with a cubic. So we've been given our 3 intercepts here, one of those being a turning point. So what that tells me is one of my factors here is x plus 2. So I can get rid of all those ones that don't have that there. Then this one here is a factor of x minus 1, but being a turning point, we can see that's going to be squared. And then this final one here is x minus 3. So we're looking at a in this case. Now for this one here, we can once again use those facts to our advantage, looking at our 4 intercepts and then our y-intercept from there. I'm going to start by doing this in factorized form. So I've got my dilation factor of a, and then I'm going to write out all of my x-intercepts, but in that factor form. So we've got x plus 3 and x plus 1 from our negative 3 and negative 1. And then I've got x minus 1, x minus 3. I'm then going to sub in 0, 9. So I have 9 is equal to 3 times 1 times negative 1 times negative 3, which means 9 is equal to 9a. So a is equal to 1. From there, we're going to have to expand our brackets here. I'm going to group my dots together because that's going to make it a bit easier. So I've got x squared minus 9, x squared minus 1. And then we're just working from there. We've got x to the power of 4 minus 9x squared minus 1x squared. So that's minus 10x squared plus 9 is my final answer for that one.